Now for something completely different. So I think from everybody else, you've heard sort of what I might describe as sort of traditional security, the usual suspects. We're fundamentally a cloud company, and so I'm going to talk about application control. I'll define it some. We'll tell a story around security, kind of how incidents that we deal with on a daily basis, and really set up how we need or why we do what we do for application control. So who we are, I'm sure you've probably not encountered us before other than out there. If I've talked to you, great. We do a lot of work in e-commerce today, not to say that we're limited to that. We view ourselves as it's an interesting vertical for us to apply our security, our application control, because it's so rife with attacks and has so many problems. So it's sort of, my view is, look, if I can succeed there and actually protect these guys with really poor discipline, if I can protect them and deliver security there, the enterprise problem's easy, right? Because in enterprise, you've got control. You tend to have discipline in how you deploy changes into production. So if I can solve this world where they have no discipline, the enterprise problems actually turn out to be pretty straightforward. So just to set up the scale, maybe the scale and Webscale. This past Black Friday was probably our biggest event yet for the companies that we work with. It's about 600 applications, e-commerce type applications, some blogs too, the bigger ones. We handled about 1 billion page views over a couple days for the Black Friday weekend. It was about $3 billion in e-commerce over the year in 2017. There's a lot of money that flows through our network, not to mention any other or e-commerce as a whole. In addition to that 1 billion page views, we made about 83 billion decisions around how to handle that HTTP traffic. So significant volume of traffic operating on a cloud-only platform that stayed secure. We didn't have any security or availability incidents during that weekend, so it was quite successful. In addition, we scaled out about 10,000 times, and this gets to some of the lack of discipline in this community. They all told us going into the Black Friday weekend, every one of our customers said, yeah, we think based on what we see in traffic, we think we need a system that's about this big. So we went ahead and we pre-baked everybody. We set them up to have clusters that were of that size. It was their best effort in capacity planning, and they were wrong in 10,000 incidents. So they have a fundamental inability to understand how successful their marketing campaigns are going to be, how successful their Black Friday traffic. So we're able to make it not a problem. We take that, what would have been traditionally if they were in hardware or deployed in a physical data center someplace, they couldn't have done this, right? Because they can't bring new capacity online to service those customers. They would have just had a failure or downtime, and they would have had an issue. So we make those issues go away. So let me talk to you some about the applications that we deal with. So they're fundamentally built on open source. There are open source shopping carts and blogs. You can think like WordPress. There's some pretty widely adopted applications, which creates this sort of security problem for us in that these applications are all open source. So as I mentioned before, there's a significant amount of revenue flowing through these applications and these open source frameworks. But that means that the bad guys have strong incentive, profit motive. They want to get into these applications and essentially design an attack to steal credit card information from these companies. And the value to attacking these application frameworks is that they're used by hundreds of thousands of companies. And so this is, I think yesterday you heard a lot about, well, the threats are imminent. They're going to get in. It's not if they're going to get in, they're going to get in. The reason they're going to get in is because the value of this open source is that the businesses can get all their feature function deployed quickly. It's effective for their business. However, it's also out there for the bad guys. The bad guys are studying the code, and there's strong profit motive. If they find an exploit, they get to get in and steal the credit card. So that's fundamentally what's going on. I can't stop it or prevent them getting in, but I can take the appropriate architectural steps to make it not an issue. So that's what we do. We provide application control to mitigate those threats as they happen. So what is application control? I'll get into it's a bit of what we do and how we change an application and its deployment in the cloud to make it work. and then we'll get back into my story about security. So an example use case of application control to mitigate this kind of problem. So what is application control? Fundamentally, and probably the one takeaway you should understand about Webscale, what we do is we make what used to be static application dynamic and responsive to the environment that it lives in. So we collect data and telemetry off the application and use that data to control the application. So we reach back in and we change how that application is deployed, what code the application is running. We may update a firewall, et cetera, to respond to the environment that we're in. We get there by separating the control plane from the data plane. So you're probably all familiar with a load balancer like an F5 or an A10 or somebody like that. That typical hardware device has control and data baked into it as well. They talk a lot about their backplane and how big the backplane is and how much data they can move across it. This is a different world. Think of a device that is just software. It's tailored for the application. It's strongly integrated into the application that it's serving. And the control plane and the data plane are fundamentally separated. So all HTTP, HTTPS traffic traverses the data plane. That's the gateway into the application. And this could be anything, right? I mean, I talk a lot about e-commerce or blogs or what have you. In our world, we see a lot of RESTful APIs. We see a lot of microservices that are connected together, deployed in the public cloud, and then interconnected to deliver some bigger functionality. So we're protecting those individual applications in addition to the bigger, shopping cart or website or what have you. So separation of control and data means that all of the HTTP, HTTPS traffic's going across the data plane. The control plane sits external to that. It's a SaaS offering. It's just deployed across multiple cloud providers. There are many instances. It's completely highly available. It's pretty indestructible, and it handles all the metadata for all these billion page views over that short period of time. It's hundreds of millions of requests a day typically, and then scales tremendously for our peak seasons, for our customers' peak seasons. So that control plane gives us an opportunity to measure telemetry. So how is the application behaving? Not just any individual web request, how it's being serviced, what was that user's experience, but also how is the server behaving, the web heads, how is the database behaving, collecting event data about everything that's going on in that application. All of that's fed into the control plane, and essentially we're monitoring everything to understand what's going on. What's the problem when there is a problem? So if we see a performance issue, if we see a security issue, say a FIM alert goes off, if that happens, we detect it first off, right? So that event comes into the control plane. At the control plane side, I can actually write specialized code to handle that event. So now I can use our APIs and actually change how the application responds to that event that just occurred. So I could reach into the cloud provider and say, quarantine a server or eject it from a cluster. I could scale out the application or replace an application server. Or maybe I modify a WAF rule to change our response. So we say, oh, well, this file appeared. I don't want anybody on the internet to access it. So I block it at the WAF. All of that customizability really allows you to take your security policy, your DevOps, how you respond to the incidents and issues that exist within your application. It enables you to institute that policy in the control plane. And then the control plane's doing it for you. So what that means is you get to spend a lot more time investigating what the bigger new threats are, right? So how you want to respond, getting the policy right so that the system can do the right thing on your behalf. So typically with our customers, it really translates into sleeping more and less critical situations that they have to stress out and respond to. And that's our goal, is to just sleep more and be rested and allow our applications to service our customers and not panic when I've got a big event coming. So that's application control. We talked about the triggered automated actions there. So with that, for the techie, I don't know, anybody technical? Am I too deep, too high? You guys, this makes sense? You understand? All right, good. Okay. So if I look a little bit closer at what's going on there, right, just to get a picture that maybe helps you understand. So fundamentally, I have some collection of application servers. Usually there's a database involved. There may be a Redis cache or something like that. Maybe Memcached, but hopefully not. We could also have, then we have our control plane. So all of the data from the application is being fed into the control plane. So this is, think metadata, right? It's what are my slow queries in my database? How much CPU are my application servers consuming right now? How much free memory do I have? Am I running out of disk space? All of those types of facts. Those events they're coming in as an event stream into the control plane. And then the control plane is making decisions about how to respond to the application and its environment. So it's making the control plane, so for example, if I see too many users on the system so that all the app servers are overloaded, I could very quickly deploy a large number of application servers in response to that. We deal a lot in customers that have real world events that drive their traffic. So it's not uncommon for us to see applications that are driven by, say, markets or security events that are out in the world, right? Where they sell something that's relevant potentially to some real world event. We see a lot of legislation changes, that kind of thing, where without any notice, they could go from normal traffic to 20 times traffic in 5-10 minutes. Our job is to keep them online even when that happens, and that's what we do. It's very akin to responding to an application layer DDoS attack, right? Only in this case, the DDoS attack is your own customers. Essentially, it was a marketing campaign that was wildly successful. And in the past, the business owner wouldn't be able to run those marketing campaigns if they're terrified of that viral traffic because it just means an outage and then a bad customer experience. But with us, they love it, and we challenge them to bring it on, make it harder for us, make us scale faster. So as you can see, right, all of this is about, this doesn't work if I'm in a data center. Because fundamentally in a data center, I've got, in a private data center, I can do some things, I can scale, I can certainly make you responsive and make the application dynamic. That's good. But if I really need to respond to a viral event, I'm going to need to burst into a public cloud. I need that capacity. I need somebody with near infinite depth. You know, it's the likes of Amazon and Google that can give me significant compute capacity in a very, very short period of time. I mean, I'm going to pay a lot for it, and I'll get that. But if it's in response to a marketing event, it's worth it. The customer is going to be able to make that money back. A handful of shopping checkouts, they sell some more product, it's going to be worth it to that customer. So with that, all right, so that's essentially application control. I mean, I said a lot, but just remember, we're going to be responsive to the application's environment. We're going to enable the application to make changes to its architecture, its deployment, in response to what's going on within the application, how users are responding to that event. In this, we still deploy your traditional mechanism. So a regular WAF is still a valuable thing, right? So I have to handle all of the known exploits. So everything that I mentioned before around an application where the bad guys are incented to read the code and design an attack against that application, because there's financial incentive. If they do it once, they're not attacking any individual domain, they're really attacking a framework. So they pick a domain that they want to go after potentially to try out these attacks. Once they've studied the code, they find the vulnerability, they'll then apply that attack to all 100,000 domains that use that framework. And so they're going to show up, they're going to find that way in. The known exploits, obviously you have to protect against those. If you don't, you're just going to get exploited that way. You just make their job that much easier. So at least they're spending the time. You can see that this motive, they want to investigate and discover a way in. You have to know they're going to find a way in, right? So at this point, you have to study, okay, well, what happens next? When they get in, what are they going to try to do? So in our case, I just walked through a simple example here where a FIM alert goes off. And we know that they use one of these exploits to deposit a piece of code in the application and somehow. So they've modified the file system in some way. Either they modify some application code or they deposited a file. Typically, you'll see an image in one of your media directories or something like that where this image has code in the header, and then they're going to cause that application server to execute the code in the header and take ownership of your machine and ultimately get to the database, deposit some JavaScript. That JavaScript goes out to the browser, and now all of a sudden the browsers are stealing credit cards from the world. So if the bad guy installs the code, they use some exploit, they add some code on the system. Now it's there. Now what? Well, that sets off a FIM alarm. I probably all use file integrity monitoring. It's pretty typical. That alert in the traditional days, I would set up some incidents. So now you set off an alarm. Some SecOps guy responds to it. Whoever's on call, they get up, they deal with the issue, and they try to make sense of what's going on. They have a security policy. What are they going to do to deal with that event? in our case, this actually starts as the event goes into the control plane. So now we just got notification of the control plane that something's been modified and we don't like it. An unauthorized change has been made, and now we can execute our automated control policy directly from the control plane and reach into the application to make some changes. So first off, that event comes with a lot of data. What server was the change made on? What was the file name? When did it happen? That information, I can use that information in my policy to actually execute. I know what server it is. I can start to make some changes to the application itself using our control software. So essentially, I'll actually call the WAF, and I'll make a change to the WAF. So maybe I blacklist that file. I prevent anybody from the internet accessing the file that was modified because I don't like it. I could also do more things. I can actually go in and quarantine the application server, just kick it out of the cluster and say, look, this thing's been modified. It's not safe to use this server. Get it out and replace it. All happening automatically. The control plane integrated with the cloud provider gives us the ability to go create new instances of those servers and automatically replace the server. Essentially tell the system that the server's failed, I don't want anybody to use it anymore because of the security incident, kick it out of the system, replace it in the system, right? So it's essentially, this is an example policy of how I might respond to a FIM event. So know that it's fully extensible and our control software is open. So you could take our control software, write your own policy in, right? Essentially put in your own API calls. What do you want to do? How do you want to respond to this incident? And then finally, just like anything, we'll get the person involved. So we're going to actually reach out into your incident management system, be it PagerDuty or whatever it is that you're using. We're going to call that incident management system and tell you, hey, there's a security incident that just happened. Here's all the steps that we've taken. Here's a link back into our portal where you can find more information. Essentially get to all of the traffic that server was processing at the time that the incident occurred, and what actions we took. And then if your policy was to eject the server from the cluster but keep it around, you can actually get onto the server and start to investigate and understand, well, how did they get in? Convert the unknown exploit into a known exploit so you can actually prevent it across your other customers or across all of your customers in our case. So after we've handled the immediate effects of that incident, so that initial automated response, now we're going to start to look at what do I want to do from the aftermath, we call it, right? So this incident occurred. I now want to take action, right? So I get this notification, hey, some security incidents occurred. There's a link back into our portal with all the relevant data. Now I can start to do things like, I know what post requests were received by this server at this particular time. Given that, I can go through that traffic and try and identify the signature of the attack that led to the change in the first place. With that, coupled with all the other events, it could be this user logged into that server, and then here's the bash history of what that user did, and now I'm going to go investigate that and see, well, maybe somebody logged in and changed the file, and that was actually the incident. I have a compromised user on my network, and I want to get them out. Or it's actually more typically in our case, it's an attack, it's a new attack on this application framework, and that the user from the internet came in and made some modification, and now we want to get that modification out. So we want to understand what that signature is and take action. So our control panel, we keep all traffic that the application processed. So of those billion requests, all of those requests are accessible via our traffic viewer. It's a SQL-like language that allows you to look at everything that all users were doing, bots, people, it doesn't matter. If it was an HTTP request processed by the system, that data is in this traffic viewer. I can go search exactly for that data about that point in time, that server that processed it. This is how, oh yeah, we have a distraction. It's like a 5 minutes. So I'm almost done, so perfect. So that user, well, you're not going to pay attention to me now.
Yes, we are.
So now that I'm investigating that traffic, I can actually get in and go find the request and the needle in the haystack, right? I know what server it showed up on. I know when it happened, and I can get down to this was the event that occurred. that that's the signature. And now with that data, I can go execute my policy. Maybe it's just blacklist some IP address who's coming at me from, this is bad traffic from that IP. Or I see the signature, I analyze it and discover, hey, that code path actually is a bigger exploit. I want to tell the community about it. I maybe want to blacklist anybody that attempts to make those requests because it's a piece of the application that's not used anymore. We see that a lot too, these kind of dead code paths that are still hanging out in the application, and the bad guy finds them and then comes in, and that's how they execute their exploit. And so with that information, I can then go do new things. I can install new WAF rules, I can block people, I can auto blacklist anybody that shows up and executes that signature again. We do that a lot too. So that if you look and present, you behave like a bad guy, we disallow you from the system because your behavior is indicating that you're not good. You're not trying to you're abusing our customer's application. With that, there's also whitelisting and a lot of other functionality here. I've only scratched the surface of what it means to use application control, but I hope, it gives you a flavor of what it means to listen to the world that your application lives in and then reach into that application and make changes in response to that. So it could be security, it could be scale, variety of instances. We also see a lot too in file system, so if I run out of disk space, that kind of thing, I can actually just grow the disk and make it not a problem. So at any rate, all of those functionality around control, if I sort of wrap it up here in my couple minutes left, we're going to monitor everything. You have to. We have to bring it into a uniform event framework so that it's actionable. So I can actually register code against those events and make changes. I can execute my policy of how do I deal with these events? When I see these events, what actions would I take? And how do I prevent this from becoming a bigger incident? I want to shorten that time from actual attack so exploit executed to discoverability. Make it faster to get to the answer. I want to enable my security team to actually take action faster so that if I present you with all of the information, everything I know about what the application was doing at that time, I'm giving you this very focused look inside the application at the time that the event occurred so that you can actually get to discoverability. You're not necessarily going to stop there, but it'll point you in the right direction to go figure out, well, how do I deal with this event, right? So what was the code that they exploited? What do I have to patch? What do I have to change to make it so they can't get in again in the future? And then we want to make it easy, obviously, to design new rule sets, apply those rule sets, manage the application after the fact, so we do that as well. And then finally, we wrap it up by taking that information. So anytime we discover that new exploit, and then we make that available to all of our customers to say, it's communicate back to them to let them know that this is going on in the world. This is what we're seeing within the applications of your type and how you're being attacked. So when you put it all together, it's just respond to the information, collect the information, be able to respond to it, and be able to take action automatically in program time to respond to those incidents. So anyway, thank you. Thanks for your time. Glad you're here. I hope I kept you awake.